Okay. So hopefully my mic works this time. So with these non-permissible values, what it is that there's a special kind of number that we're not allowed to have in the denominator of any fraction, right, or any rational expression, and that's going to be zero. You're not allowed to divide by zero, right? Because like, what would it even mean to say? Let's say if I had something like 5 divided by 0, it's not that that's infinity, and it's not that that's zero, right? Like that's nothing else. Like it doesn't even work. It doesn't even actually like make any sense, right? Um, so yeah, exactly there. So x cannot be equal to 2. So that's the idea. Is if I'm looking at the bottom, I'm just saying for my non-permissible values, is that what is x not allowed to be? So what we can do, you can probably just see from looking at it that it can't be 2, right? Because if x was 2, then that would be 1 over 2 minus 2. So that would be 1 over 0, which isn't allowed. So what we do here is we'd say, this is our expression, and you'd say where x is not allowed to be equal to, that's like an equal sign with like a dash through it, and that's not allowed to be equal to 2. All right, so that's my non-permissible value. So now, this was pretty straightforward, but what about this one, right? It's not as easy to see what is not allowed to be there. So a good way to do them when they're looking like that, when there's like some number like multiplied by x and then minus 1 or minus something, a good way to do this would be to set it up where you say, okay, I know that the bottom can't be equal to 0. So let's just write that out for a second. We'll say, okay, 2x minus 1 is not allowed to equal 0. Okay? Or I could just say is equal to 0 for a second. And I could say, okay, well, let's do a little algebra here. Let's say I'm going to add 1 to both sides. So plus 1 plus 1. So I get 2x is equal to 1. And then I'm going to divide by 2. Divide by 2. So x is equal to a half. So what that means is, like, I set it equal to 0 to figure out what x would have to be. But my non-permissible value here would be x is not allowed to equal a half, right? And that makes sense. If I threw a half back into there, that would be 2 times a half is 1 minus 1, that'd be 0, right? Which you can't have. Okay, so that's our non-permissible values. Okay, I'll be doing more of those as we go. But actually, you know what? Let's do a few more here too, because if I look at this one, this isn't so obvious, you know, what it's not allowed to be. What you always want to do, what we want to do as we're moving on here, is you always want to factor it, because it's going to be a lot more clear when I'm looking at it after I factor it. So I'm going to rewrite this as -1 over, and then factoring this guy, I can see that they both have an x in them. So I'm going to factor out an x. I'm going to say, okay, x. I'm going to start a bracket and then write what I have left. So I'd have x times x plus 3. All right. So now it's a little bit easier to see. I'm looking at the bottom there, and I can say, okay, well, like, here's the idea, is that I am going to say what value for x would make the bottom 0. Well, can you imagine that if I put a 0 in for that x right there, right? No matter what this is, right? Because I'd put a 0 in for both, but I don't even really care. If I put a 0 in for this, then that would be 0 times this, which is 0, right? So it doesn't matter. So if I get an x just sitting on its own like that, without, like, you know, plus 3, plus 2, or plus anything, or minus anything, just sitting on its own, then what that means right there is that x is not allowed to equal 0, right? Because if it was 0, then the whole bottom would be 0. So that's one of my non-permissible values. But then the other one comes from looking at this one. What else would it be? Well, if this x, right, if I made that x equal to -3, then the whole thing would be 0, because -3 plus 3 is 0, times anything is 0. So x is also not allowed to equal -3. So it'd be those two things. So what this means is that x can be any number in the universe other than these two numbers. Hopefully that made sense. Sorry, I shouldn't have erased that. Okay. Here, let's look at now like one of these where we got to factor it a little bit more. So we'd have -15 over, and then this is one of those special ones where you've got x squared and then an x and then a number. So I'm going to write that out as just, I'll put my brackets down. They both get an x. And I'm looking for numbers that multiply to 2 and add to 3. Okay, well, 2 and 1, that's all it can be, right? And then multiply to positive 2, add to positive 3, so that'd be plus and plus. So now looking at this one, I look at this part of it and I say, okay, well, what would x have to be right there? X is not allowed to equal -1. And in this part, you'd say x is not allowed to equal -2. Those are my non-permissible values, right? So it goes by a few names too. You'll get, those are your non-permissible values. Those are also called your restrictions. And you'll also see it as that's your domain, because the domain of any function is like the numbers that, like if you were to graph some function, right? The domain is like what x is not allowed to be there. Not sure what you mean there, Pedro. But okay. So that's pretty much it. So you guys don't, if you're part of like my COVID group, you don't have to do these questions. Maybe you do in the future. I'm not sure, but I'm going to reuse this video. So, so you guys don't right now for my COVID students. But now 4.2, so simplifying rational expressions. Okay. So let's do a few here. Yeah. So Pedro, yeah, I think, yeah, it'd be the same thing. I think just going by a different name here. Yeah. Yeah. You probably just have a different way of factoring there. I'm thinking is what you're talking about. Yeah. Okay. So simplifying rational expressions. All right. So you guys just have blank, or maybe you have some blank notes. If you don't, just a blank piece of paper. But here's the idea. We're going to have an expression like, let's say we have 3x squared over, 2x, right? And we're simplifying this. Okay. Well, what we're going to do, here, I'll call that number 1. What we're going to do is, well, first you look at your numbers to see if there's anything you can simplify in those numbers. And if not, then they'll just kind of stay the same. But if I'm looking at the top, there, then I can see if I'm just focused in on this one, I've got x squared over x. Well, you can think about that 2 ways, right? Just if we move over here for a second, x squared over x, that's like x to the 1. Oh, sorry, 1 sec. I gotta plug my computer in. I made it. Okay, so that's like x squared over x to the 1. Okay, so using our exponent laws, right? If you're dividing those, that'd be the same thing as subtracting. So that'd be the same thing as just saying that's equal to x, right? Or x to the 1, right? Or another way of looking at that is that's the same thing as like x squared would be x times x over x, and then 2 of those x's cancel, and I've got 1 left up top. I prefer to think about it as that way, right? But yeah, either way. So looking back at this one now, all we really have left is 3, and then x squared over x is just x, and then it's over 2. And just the other thing I want you guys to get a little bit used to as well is that this could be written different ways, right? This could also be written as 3 over 2 times x, right? That'd be the same thing. Okay. All right. So let's give you another one here. So we're going to have, let's say 8a squared. Let's go b to the 3 over 4 a and then b to the 6. And we're going to simplify this guy. Okay, so it's really just piece by piece, right? So let's do the numbers first. So I'd say 8 over 4. Well, that simplifies down to just 2. So it's like I've just got a 2 like on the top in the numerator. And then looking at the next chunk, I've got a squared over a. Okay, well, that would just be A. Okay, right? Just like we just did. Now looking at this one, I can see, again, what I could do here, it's a little bit more awkward doing it the other way, is I could say this is b to the 3 over b to the 6. That would be b to the, and what do we do when we divide? Well, we subtract, right? So 3 minus 6, that'd be b to the negative 3. Well, that's true. You can think about it that way. B to the negative 3 is the same thing as like 1 over b to the 3. And this is why I don't really like this, like thinking about it this way as much. I'd rather think about it as, okay, I've got 3 b's up top and 6 b's on the bottom. 3 of these b's are going to cancel with 3 of the b's on the bottom, right? It's like the 6's are going to go to battle with the 3's, and the 6's are going to win by 3 in the end, right? So when those guys are all said and done, the bottom is going to have b to the 3 still left over, right? They like those cancel with like 3 of those. You have b to the 3. Okay. All right. So that's how those guys would simplify. What else here? Okay, let's do like one more. Well, here, let's do one like this. So we'll say number 3. So let's say we've got 15x squared. No, x. So 15x to the 3 minus 5x over 15x to the 3. And we have to simplify this one. Okay. Now, well, first off, what I should have been doing in the other ones as well, but I didn't, is I should be saying what my non-permissible values are or what my restrictions are, right? So again, what I'm going to do is I'm going to look at the bottom of this. I'm going to look at the bottom of this guy. I'm going to say, okay, well, x is not allowed to equal something. It's not allowed to equal some number. Well, in this case, it's not allowed to equal 0, because you can imagine if I threw a 0 in for that, like 0 to the power of 3 is still just 0, times 15 is still just 0. So like 0 is the number it can't be. So right off the bat, my non-permissible value is 0. Now, the next part here is I need to, I could, maybe you're thinking I could start canceling things like I did here, but I actually can't yet. And the reason for it is this subtraction simple. I've got a binomial on the top here, right? I've got 2 terms. I've got, this front term and the second term, and they're subtracting. And here's the idea is that they are both over 15 over x to the 3. And why that matters is because the main mistake that kids will make here is they'll do this. They'll say, oh, x to the 3 and x to the 3. And they'd cancel those and they'd think that they were good to go. It doesn't work that way. And the reason it doesn't work that way is because when I canceled this x to the 3 with this x to the 3, it's like I just pretended that this part of it wasn't also over the x to the 3. And here's what I mean. Maybe it'll make more sense. This could also be written like this. It could have been written as 15x to the 3 over 15x to the 3 minus 5x over 15x to the 3, right? Like you can rewrite it. You can rewrite this thing, this one over here, as instead of like 15x to the 3 minus 5x to the 3 over that, you can rewrite it as that underneath both of them, right? That means the same thing. So when I just went, when I just tried to cancel this one and this one, like by canceling like this one and this one, it's like I pretended that this wasn't also there. Okay, if you're having a hard time with that, just you can also remember that you can't just cancel them right off the bat, right? So what we always want to do before we get going to avoid doing this incorrectly is you always want to factor out first, because if I factor something out of the top, then it's free game, right? Because whatever I factor out is common to both. So if I factor like out in a second here 5x, that's going to be common to both, and then I can cancel it. So that's what we do first. We always factor first. So I'm going to say, okay, what's common to 15x to the 3 and 5x? Okay, well, 5x is, right? 5 goes into 15 and 5, and x goes into x to the 3 and x. So 5x, right? Start my bracket, and then I've got 3x squared minus, and then what do I got left here? Well, you might say 0, but I still have 1, right? Because what I'm doing when I'm factoring is dividing it out. So I've still got 1 left. All right, so that is the top one factored. and that's over 15x to the 3. Okay, now that it's looking like this, now what I can do is I can look at this part of it, right? Everything I factored out in the top there is free game. And it's like I've just got, you know, something like above, right? Where I just had numbers over top of numbers there. So now I can simplify the 5 and the 15 and the x and the x to the 3 on their own. So let's write this again. So we've got 5 and 15. That would simplify to, well, the 5 would cancel and I'd have 3 in the bottom, right? Or that's like 1 over 3, it'd be the same thing. So that would be, you can write it, that'd be like 1 on the top, 3 on the bottom. And then on with the x's, one of those x's would cancel with one of those, and we'd end up with x squared on the bottom. And then on the top, we've got all of this still, right? So you're still going to have, like in brackets, 3x squared minus 1. And then this could be written different. Like this would be right? That would still be right. But that whole thing could be simplified down to 3x squared minus 1 over 3x squared. Oh, sorry, not 3. Yeah. Yeah, 3x squared. Yeah, exactly. Yeah. Okay. So hopefully you guys are doing all right with that. Can't really see your faces to tell if you're nodding along like you get it or you don't. All right. So let's just do a couple more, right? So there's lots of practice. So let's do one like this. So we'll say 6m squared minus 8m over 3m to the 3 minus 4m squared. Okay, so first off, let's say, what are our non-permissible values? I think that was number 3, right? Or 4? Yeah, 4. So our non-permissible values, what are we not allowed to divide by? We can't divide by 0. It's hard to tell what I can't divide by when it looks like this, right? So what I'm going to do is I'm going to factor it. And tell you the truth, what I'm going to do is I'm going to factor them both right now, because I'm going to have to factor the top anyway. So let's just factor them both. So what goes into 6 and 8? Well, 2 does. And then what goes into both of my m's there, right? M and m squared? Well, m does. So 2m, start my bracket. And then 6m squared divided by the 2m, or like 6 divided by 2 is 3. M squared divided by m is just m. Okay. And then 8 divided, or negative 8 divided by the 2 I took out. So I'm at negative 4 or minus 4. And then the m's gone. So there's my top. And the bottom is, well, I'm going to factor out, it looks like all I can factor out is an m squared. I can take out a whole m squared there. So m squared, start my bracket, and then I've got 3m minus 4. Oh, that worked out nice. So yeah, before I start canceling anything here, I'm going to look at this guy, right? So that's when you want to look at your non-permissible values, is before you cancel things, right? You can't cancel and then look at the bottom. You have to look at it before you cancel. So looking at this, I'm looking at my m squared, and that would be 0, right? If I threw a 0 in for that, then that would make the whole bottom 0. So m's not allowed to equal 0. And it's also, so I'll just put like a comma, not equal to, well, we'll have to do a little math here. So for this one, you'd say, okay, 3m minus 4, and I'm going to set it equal to 0 to do a little algebra here. Okay, so I'm going to get m on its own, so I'll add 4 to both sides. So plus 4, plus 4. So I've got 3m is equal to 4. Then we have divide by 3, divide by 3. So m is equal to 4 over 3. So that's what my non-permissible value is, right? M's not allowed to equal 4 over 3. So that's the other one. Okay. Now we're actually at the easy part now, because since I set this up where we've got 3m minus 4 and 3m minus 4, and both nicely in brackets like this, right? Like that's a thing. That's just like one chunk that I'm able to cancel that out now, right? I can take this whole thing and cancel all of that with all of that. So that gets to go away, right? That's all just equal to 1. And then on the what's left there, we still got some m's we can take care of. So I've got an m over m squared. So that m would cancel with one of these m's on the bottom. And then all of that in the end would just be equal to 2 over m. And then with those restrictions, right? That'd still be my restrictions on it. Okay. So that's the idea, guys. Let's do some more with another type of factoring. So let's do this one. So I'll say x squared minus 7x plus 10 over x squared minus 4x plus 4. All right. So I can't really see much of anything to cancel in this one, right? Like I can't, I'm not allowed to just cancel those, right? Because that's like ignoring that it just, yeah, the whole thing is messed up. What I have to do is I have to factor out and see what's common to everything before I'm allowed to start canceling, right? So step number 1, always the first step, we want to factor. So let's look at the top and the bottom. I'll just factor them both. This is one of those special cases, right? We've got a square and then an x and then a constant on the end. So the way we factor those ones is we just write down our brackets. They both get an x. And then I'm looking for numbers that multiply to 10 and add to 7. All right, so remember, if I'm looking for numbers that multiply to 10, sometimes I just write down like the numbers. So I'd be like maybe 10 and 1. Okay, well, yeah, maybe, but 10 and 1 is never going to add to 7, add or subtract, right? So it's not 10 and 1. But what about 5 and 2, right? 5 and 2 seems promising. So 5 and 2, okay? And they need to multiply to positive 10. Okay, so they got to multiply positive 10. So there's 2 ways that can happen. They could both be positive, or they could both be negative, right? Because if they were both negative, then negative 5 times negative 2 is positive 10. And it worked out nice because negative 5 minus 2 is negative 7. Okay, so that's the top factored. And then we'll do the bottom. So again, similar. They both get an x, right? That one and that one. And I'm looking for numbers that multiply to positive 4 and add to negative 2. Okay, so maybe 4 and 1. But no, I'm not getting from 4 and 1. I'm not adding to negative 4. So I'm going to go 2 and 2. Right? So again, I got a similar situation. I got to multiply to a positive. Well, that only happens if they're either both positive or both negative. And in this case, I need them to be both negative, right? Because now they're going to negative 2 minus 2 would be negative 4. Okay, so now what are my non-permissible values? Well, I can see from here, my non-permissible values, x is not allowed to equal 2. And that's for both of them, right? So that's the only non-permissible value there. Okay. And then now I'm going to go to town canceling. There's just one I can cancel here, right? I get to cancel all of the x minus 2 with the x minus 2. So in the end here, my answer would be
I can't hear you.
We can't hear you again.
Can you hear me now?
Yeah.
Yeah,
Have you not been able to hear me for a long time, or was that just now?
Just
just
out.
now.
Okay, thank God. I gotta get that fixed apparently. Okay, yeah. Do you guys have any more questions though? That's really the gist of it. Like I've even been taking questions from your assessment, right? Do you want me to go through a few more, or do you think you're feeling confident with it? Oh, you know what? I'll do one with a difference of squares. Those ones might screw you up. I'll do one more. Okay, so let's go x squared minus 25 over x squared plus 4x minus 5. All right, so we're looking at this one. Again, what we want to do, we always want to factor. But this is why I wanted to do this one, is because this is that other special type of factoring where I've got a perfect square and a perfect square, right? That's a difference of squares. And the way we handle those is we can write down our brackets and they both get an x, just like before. But then the way this works is it's going to be, well, the square root, right? So the square root of 25 would be 5 and 5. So they both get a 5. And then one's plus and one's minus. All right. And then that is over. And then we'll look at this one. So throw our brackets down. So x and an x. And then I'm looking for numbers that multiply to -5 and add to 4. Okay, so there's not many that multiply to 5. There's really only 5 and 1. And that kind of works out because 5 minus 1 gives me 4. So I'm going to try to get there, right? And I'm multiplying to a negative. So to multiply to a negative, one's got to be positive and one's got to be negative. So let's say that I made this one negative. I'm like, okay, this is negative and this is positive. Well, I can just double check that and say, okay, well, -5 plus 1, that'd be -4, not +4. So, okay, I just got that backwards. Okay, so that should have been +5 and -1. Okay, and now looking at this, I can see, well, I got x plus 5 on the top, x plus 5 on the bottom, and this would be x minus 5 over x minus 1 would be your answer. And then where x is not allowed to equal, oh, I forgot to do the non-permissible values. So what is x not allowed to equal? Well, from this guy, x was not allowed to equal 1, right? And then from this one, x was not allowed to equal -5. Okay, and that should be it. So I'll end the video here.